Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to talk about limits, of a function. Say, for example, we are given, a function y equals to f of x that is defined somewhere. And we ask, what does the limit of this function as x goes to a mean? What is this? Basically, it means as x, this means as x gets closer and closer to a, then what is the values of f of x are getting closer to? So f of x gets closer to what? So the limit of f of x as x goes to a means when x is getting closer and closer to a, f of x is getting closer and closer to what? This is the value of the limit. However, when I have x gets closer and closer to a, I have two possibilities. Say, for example, this is a, then I can approach a from the right-hand side or from the left-hand side. From either sides, when x goes to a, the value of f of x is getting closer to what? This is the value of the limit. Now I will give examples. Now let's see some examples. Here, for example, part A, let's find the limit of the function x plus 1 as x goes to 2. Basically, what it means, we are taking x values, going to where x is going to what? To get closer and closer to 2, and we are going to test the function values, x plus 1 are getting to what value? This is the value of the limit. Take values that are getting closer and closer to 2. For example, one way, as we said, before, you can take values, in the right or in the left side. So, for example, when you take, say, for example, 2.1, these values are going to be 3.1, when you take closer to 2, say 2.01, then x plus 1 is going to be 3.01, and so on. When you decrease this so that it becomes closer and closer to 2, so 2, for example, 0.001, it becomes 3.001. As you can see, when you go further, you can see that as x goes closer and closer to 2, these values are going to be closer and closer to 3. Same thing, for example, if you take for example values of x where x goes to 2, but from the left hand side. So this is 2. So when you take values from the left hand side, say for example 1.9, 1.9 is very close to 2, so x plus 1 is going to be 2.9. When you take values closer even, to 2 from the left side, it will be 1. Say for example 99, so this will be 2.99. As you see here, when you are getting closer and closer to 2 from either side, you are getting closer and closer to 3. So this one, in fact, is approaching 3. So the value of this limit, in fact, is 3. Let's see another example. This example, the limit of the function x squared, minus 3 as x approaches negative 4. Now with your calculator, when x approaches negative 4, you know the x squared, is going to approach 16, right? When you take values near negative 4 from either side, then the x squared is going to be very close to 16. So the x squared is getting closer and closer to 16. So 16 negative 3 minus 3. So this will be 13. Very simple. Now this problem is very nice because look here, the limit of the function x minus 1 divided by x minus 1 as x is getting to 1, you might say this is 0 over 0. Yes, it does take this form. Okay, it is of this form, right? Of this form. Yet this function has a limit as x goes to 1. To see this, for example, make a table, okay? Make a table. Say this is x, okay, and this is x minus 1 divided by x minus 1. Okay, take values that are getting closer and closer to 1. Say, for example, 1.001. This is very close to 1, right? So 1.001, and when you just when you just substitute in here, okay, so it will be 1.001 minus 1, so this will be 0.001 divided by 0.001, which is exactly 1, okay? And when you take some, say, a closer value, say 1.0001, okay, when you substitute here, this will be 0.001, okay, divided by 0.0001, which is also 1. In fact, when you take from either side, okay, either side, as we said before, okay, the values, in fact, you will discover all of them are 1. Why is that? Because here, when we say x goes to 1, it does not mean that x is equal to 1, okay? Therefore, this 1 is not 0 over 0. This could be a very small number divided by a very small number. So this limit, in fact, is what? Is the limit, this quantity is 1. Because here, x is not equal to 1. X is getting closer and closer to 1. So this quantity is basically 1, and we have here x goes to 1. So as x goes to 1, this value does not change, okay? It is fixed, it is 1, it's always 1, okay? And therefore, it's going to be just 1, okay? Let's see now how to find, okay, limits of functions from their graphs. See, for example, this function y equals to f, its graph is given by this, okay? And the first question is, find the limit of f of x as x approaches to -2. So our question is, when x is getting closer and closer to -2, the function f of x, the curve, is getting closer and closer to what? So let's see the point -2. This is the point -2. So when I approach -2 from either side, okay? So let me hold, for example, my finger for x and the other finger, the point y corresponding to this x. You see, when x is approaching -2 from here, okay, you see the value is what? -4. Similarly, when you approach -2 from this side, okay, if you just follow the curve, okay, it will be just what? -4. Okay, so this value is basically -4. Good. Now let's find the limit of the function when x is approaching -1. Where is -1? This is -1. Okay, so when x is approaching -1, so say, for example, you are here, okay, this is x and this is y. Okay, when you are approaching -1 this way, so you are heading to what? Y equals to 0. Similarly, from the right side, okay, when x is approaching -1, you see the curve is going toward what? The value y equals to 0. So it will be just 0. Now the third question is, what is the limit of the function as x goes to 2? Now as x goes to 2, this is 2, right? Okay, when x goes to 2 this way or this way, you just follow the curve. Have your finger, one finger for x and the other finger, the value of x that corresponds to this x. So you see here, as you get closer and closer to 2, okay, you are getting closer and closer to what? to 4. Yes, the function is not defined at this point x equals to 2. Yet, as you get closer and closer to 2, the curve is getting closer and closer to what? To the value 4. From either side, see here also, okay? See, when this is for x and this is for y, as x goes to 2 from this side, this is the value of x. Look, it is getting to what? The same value 4. So the limit of this function is equal to 4. As you see here, the function can have a limit while it is not defined at 2. See, this function is undefined at 2 because 2 is not in its domain. You see, it's just open here. Yet it has a limit as x goes to 2, not as x equals to 2, as x goes to 2. So when x is approaching 2, the values of the function is approaching 4. Okay, let's see this example now. The limit of the function as x is approaching 3. Now, as x is approaching 3, I will test this. So from this side and this side. Okay, so from the right side, say here, okay, this is x and this is f of x. As x approaches 3, the value of f of x is approaching what? 2. Right? Is approaching 2. And similarly from this side, when I approach 3 from the left hand side, look, I'm approaching the value 2. Okay, so it is 2. So the limit of the function as x approaches 3 is in fact 2. Look here, what is the value of the function at this point? Is the value of the function at 3 is in fact 4. But the limit of this function as x goes to 3 is going to be 2. Basically, we ask this question. As x is approaching 3, the curve is going to go to where? To be closer to where? To be closer to, in fact, this point. Okay, we are going now to talk about one-sided limits, okay, which means that the limit as x goes to the number, it's going to it from one side, either from the left side or the right-hand side. For example, when we write the limit of the function f of x as x approaches a from right, what does that mean? It means as x approaches a, but from the right side, that's why I'm writing plus. So when I write a plus, it means x approaches to a from right side. Now, take this point here, a. When you are approaching a from right sides, okay, it means you are taking values that are greater than a, right? So all these values will be greater than a. So x approaches a, but what? X must be greater than a. So as x approaches a from the right, okay, then f of x approaches what? Say, for example, it approaches L. Then the value of this limit of f of x as x goes to a from right is going to be L. Similarly, for example, when we take x goes to a from the left side. So take, for example, this is your a, and you wish to approach a from the left side. So it is this way. This means you are taking values of x which are less than a, right? So this means, this limit means that x is approaching a, but x is what? Less than a. Okay, because it is approaching it from the left side. So as x approaches a from left, okay, then what? Then f of x is approaching what? If it approaches, for example, L, then this value, the value of this limit equals to L. Let's take an example. Let's see now the following interesting example. This function, the graph of this function y equals to f of x, you see the graph of this function has a jump at x equals to 4. Let's see the importance of one-sided limits here. You see, the first one, the limit of the function of x as x approaches 4 from the right side. Look, this is the plus, means the right side. So this is 4. So I'm going to approach 4 from the right side. So as I put my finger here, one for x and one for y, if I go and approach 4 from the right side, you see the curve, I'm just tracing the curve and it's getting to what? To 5. So this limit, in fact, is equals to what? Is equals to 5. Now let me see the limit of this function when x goes to 4 from the left. So now I'm going to approach 4 from the left side. So this is x and this is the y value. As I get closer and closer to 4 from the left, okay, the values of the function are getting closer and closer to this point, okay, which is what? 3. So from this side, it's going to be 3. So we see here in this example, the limit of the function from the right-hand side at the point 4 is different from that from the left. And you see the value of the function at 4, the value of the function at 4, it's not this value because it's open, okay, it is rather this value, which is what? Which is 3. As you see, the value of the function at some point could be very different from the limit of the function to that point. Okay, now let's see another interesting example, okay, of finding limits of a function from its graph. So for this function y equals to g of x, we would like to find first the limit of g of x as x approaches 2 from the right. So as x approaches 2 from the right, so it is from this side, so if I trace the curve, okay, I see that the points are getting to what? To 4. So this value is 4. Very good. While if the limit here of g of x as x approaches to 2, approaches 2 from the left side, so approaches 2 from the left side, okay, when I trace the graph of the function, okay, when I trace the curve, I see my finger, the y values is going to what? Is going to 2. So this value is going to be exactly 2. Let's see now part B. The limit of the function g of x as x approaches 0 from the right-hand side. So from the right-hand side, this is the 0. Okay, so I'm approaching 0 from the right-hand side. Look, when I trace the curve, okay, the curve as x approaches 0, the curve is going down and down to what? Toward y equals to 0. Okay, so this one is basically 0. Okay, very good. Now part C. Where am I? Okay, no, it's not here, okay? The limit of g of x as x approaches 0 from the right. So as we are approaching 0 from the right, the value is what? Is 0. We are here. Very good. Now the second one, the limit of g of x as x approaches 0 from the left. So as x approaches 0 from the left this way, so this is my x and this is my y. So as I approach 0 from the left, I see the curve is going toward y equals 0. So it is 0. Let's see the final one, the limit of the function g of x as x approaches -2 from the right. -2 from the right. So this is -2 here, okay, from the right. So I'm approaching -2 from the right. So you see here, as I approach -2 from the right, I see the curve, the y values, okay, is getting toward what value? 2. So the value is 2. Very good. And when I approach negative, you see this question, the limit of g of x as x approaches -2 from the left. -2 from the left will be this way, right? So when I approach -2 from the left, so look here, this is x and this is y. So if I just keep going, okay, then this way, it's getting to what? It's getting to exactly 2. So the value here is 2. Now, one remark in this question. We saw in part A, for example, the limit from the right-hand side is not equal to the limit from the left-hand side at this point 2. In fact, you have a jump here, right? Okay, due to this jump, in fact, you have the difference in the limit from the right-hand side limit, the right-sided limit, and the left-sided limit. Okay, look here in part B. The limit from the right is equal, in fact, the limit from the left of the function as x goes to 0. So the limit does exist. So we have values for this limit and this limit. Yet the function itself at 0 is not defined. Okay? So we can have values for the limits while the function itself is not defined at that point. Now look at this example. Okay, this function has limit from the right hand side equals to 2 and from the left hand side equals to 2. So this is at negative 2, right? So when x approaches negative 2 from the right or left, the limit is 2. It is defined at this point negative 2, but its value is different from the limit. Okay, see here g of negative 2 is what is 4, while its limit, it is something different. Okay, the limit from right is 2, okay, and the limit from left is 2, while its value at that point is something different. So the limit of a function where x is getting to a number has nothing to do with the definition of the function at that point, but there are particular cases when the function, in fact, is, as you are going to see in coming sections, when the function is continuous, then in fact the limit from the right hand side and the limit from the left hand side and the value of the function at that point, all of these must be equal. Stop. Okay. Okay, let's see now how together we solve this interesting example. So let's find the limit of this function x squared minus 1 divided by x squared minus 1 as x goes to 1. Well, from the first, okay, from the first look to this question, okay, you would say, well, as x goes to 1, this goes to 0, isn't it? And this as well goes to 0. 0 over 0 is undefined, okay? But this is not the way how you should treat the limit. You see here, as x approaches 1, this one is going to approach what? See here, this one is the limit as x approaches 1. This is not yet equal to 0. This is something not equal to 0 because x is getting closer and closer to 1. So this quantity x squared divided by x squared minus 1 divided by x squared minus 1 is basically what? 1. So this is the limit of the function 1 as x goes to 1, which is exactly 1. Okay, very simple. Let's see the second one. Here too, when x goes to 1, 1 cubed minus 1, you will see this is going to be 0 and the denominator is going to be also 0. Okay, don't rush and say the limit does not exist. Okay, try to make a conclusion to this because you cannot say it does not exist as well because it has this form only. So you will have to deduce that it does exist really or it does not exist. Okay, here our problem is what? As x minus 1 is getting to 0 as x goes to 1. Think, can you factor, can you multiply by conjugate, can you do anything that you have studied, okay, in previous courses so that you can get rid of the problem having 0 in the denominator. For example, here I can see that x cubed minus 1 can be factored out, which is what? X minus 1 times x squared plus x plus 1. All right. And the denominator is what? X minus 1. And here as x goes to 1. I can see that these two can cancel out because this is not 0 over 0. X is getting to 1. So what is this limit? This is the limit of the leftover quantity, which is x squared plus x plus 1 as x goes to 1. All right? So see here, as x goes to 1, this quantity is getting closer and closer to 1, and this one is getting closer to 1, and this one, so you will have what? 1 plus 1 plus 1, so it is 3. Very simple. See, also this case, I forgot to write, okay, here as x goes to 0. Okay, as x goes to 0, what is the limit of sine squared of x divided by 1 minus cosine x? Well, again, okay, think about it, okay? Look here, the denominator is 1 minus cosine x. The denominator is a problematic because as x goes to 0, 1 minus cosine 0, cosine 0 is 1, 1 minus 1 is 0. Can you get rid of this situation here? Well, I recall, okay, that sine squared plus sine squared x plus cosine squared x equals to 1. Therefore, I can deduce directly sine squared x equals to just what? 1 minus cosine squared of x. All right, so it is 1 minus cosine squared of x as x goes to 0. Almost done. Here, if you see, this is the difference between two squares, and you will get, in fact, one of its factors is 1 minus cosine x. So this is the limit. I can factor this out, okay? So it's going to be 1 minus cosine x times 1 plus cosine x divided by 1 minus cosine x as x goes to 0. You can see here, these quantities, okay, cancel out because they are not 0 yet, okay? And therefore, it is equal to what? It equals to the limit of the leftover here, 1 plus cosine x as x goes to 0. Now you study the behavior of this function. As x goes to 0, you know the cosine function as x goes to 0, the cosine function, okay, is going to 1. So this will be 1 plus 1, so which is going to be 2. Very simple. All right, let's see how to solve this problem. Finding the limit of x to the power 4 minus 16 divided by x cubed plus 8 as x goes to -2 from the right hand side. As you see here, if you go first and study this quantity as x is getting to -2, okay, this quantity upstairs will be -2 to the power 4, that is 16, okay, will be close to that, 16 minus 16 divided by, and this one is getting to -2 to the power 3, so that is -8, is -8 plus 8, which is again of the form 0 over 0. Okay, we cannot say the limit does not exist because of this. We have to prove it. Okay, in fact, the limit will exist as we are going to see. Well, as we said earlier, okay, we try to do something, multiplying by conjugates, okay, using some identities, whatever, that let this situation having 0 in the denominator to be away. So let's see. X to the power 4 minus 16. This is a difference between two squared, isn't it? Okay, two squares. Okay, so it's going to be x squared minus 4 times x squared plus 4. Very good. And x cubed plus 8, x cubed plus 8, this is, in fact, the sum of two cubes. Okay, see, this is x cubed plus 8, 8 is 2 to the power 3, so this one is going to be what? This one is going to be x plus 2 times x squared plus 2 times x plus, there's a negative sign here, yeah, and this one squared, so plus 4. So it's going to be x plus 2 times x squared negative 2x plus 4. Okay, almost done. Okay, we are, look here, this one has no problem because when x goes to negative 2, this one to 4, so 4 plus 4 is 8, plus 4, that's 12, this is fine. The problem is in here, x plus 2. This is getting to 0 as x goes to negative 2 from the right-hand side, or from the left side, same thing. Here, how can we get rid of this? Well, you can use this one. You can factor this one out, and you will get, in fact, one factor of it, x plus 2. So let's do that. So this one is equal to the limit as x goes to negative 2 from the right-hand side of, I will factor x squared minus 4, so it will be x minus 2 times x plus 2 times x squared plus 4, okay, divided by x plus 2 times x squared minus 2x plus 4. All right, I can now cancel this with this one. Okay, here remember, we factored things here because we have a problem in the denominator. We have a form of 0 over 0. If we haven't this form, okay, if we haven't had this form, then we would not need, we wouldn't need any factorization here. So what do we have left here? So this is the limit of x minus 2. This one is gone. So x minus 2 times x squared plus 4 divided by x squared negative minus 2x plus 4 as x goes to negative 2 from the right side. In fact, here it will not matter when x goes to negative 2 from the right side or the left side because you have just polynomials, okay? Here, when x goes to negative 2, you will observe that the numerator, okay, the numerator is getting to what? If x goes to negative 2, so it will be negative 2 and another negative 2, that is negative 4. Okay, and this guy here, when x goes to negative 2 from the right, okay, it will be negative 2 squared. Okay, so this will get closer to 4 plus another 4, that is 8. Okay, and here when x goes to negative 2, this will go to 4. Okay, and negative 2 times x goes to negative 2, so this will go, the whole thing, okay, will go to 4. And this one is 4, so you have 12. Now you can simplify 4 and the 12, you have 1/3, so this will be minus 8 over 3. So this is the value of the limit. So as x approaches negative 2 from the right-hand side, the limit of this function, x squared minus 16 divided by x cubed plus 8, is in fact minus 8 over 3. See here, be careful when you have 0 over 0 forms. It means you have to do something to get rid of this problem. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we are going to talk about when does a limit of a function exist. See here, the limit of a function y equals to f of x as x approaches a. We know when we write x goes to a, it means x goes to a from left and x goes to a as well from the right-hand side. So we will say this limit exists. We will say this limit exists if the limit of this function as x goes to a from left equals to the limit of f of x as x goes to a from the right side. Both of them are equal to a number, say for example L, where L here is a finite number. Okay, this is it. Now, if this condition is not satisfied, then this limit, we will say this limit does not exist. So we'll say otherwise it does not exist. And we will abbreviate this by writing D does not, N E for does not exist. Okay, let's see an example here. Here we are given the function y equals to g of t. This is the t-axis and this is the y-axis. And we would like to find the limit of each, okay, if the limit exists. See part A, I'm finding the limit of g of t as t approaches 2. So in order to check if the limit exists or not, I'm going to find its limit from left and its limit from right. If both of them are equal to a finite number, then the limit exists. So the limit of g of t, let me take first, say, t goes to 2 from the left side. As t goes to 2 from the left side, it is from this way. If you just track the y values as you approach 2 from the left side, it will be 1. So this limit is just what? 1. Now let's make sure and see the other one. What is the limit of the same function as t goes to 2 but from right? So I'm going now to approach 2 from the right hand side. So let me put a finger for x and the other finger for y, and I'm tracking now the y values as t approaches 2 from the right. So as t approaches 2 from the right, you see here the values are getting closer and closer to 2. You notice here the limit from the left side and the right hand side are not equal. So this limit does not exist. Let's see the other. Let's see the limit of g of t as t approaches -2. Okay, so let's see here. Let's find first the limit of g of t as t approaches -2, say from left. Okay, when I approach -2 from left side, okay, here are the t values, and these are the g of t values. Okay, as I approach -2 from the left side, you know, the y values are getting closer and closer to what? To 1. So this is 1. Okay, number 2, the limit of g of t as t goes to -2 from the right side. Now, when t goes to -2 from the right side, it's from this side, right? So here are the values of t, and these are the values of g of t. As t goes to -2 from the right side, you observe that the values, okay, are getting closer and closer to 1. Here in this example, you see the limit from the left hand side and that of the right hand side are both equal, okay, equal. They are equal. They are equal to a finite number. So this limit is basically going to be 1. So here it exists, and its value is 1. Hello again. In this question, okay, we want to find a number a that makes the limit of x as x goes to 1 exists, where the function here y equals to of x is a piecewise function that is defined to be a minus 2x for x less than or equal to 1, and the function of x is equal to 5x plus 9 for values of x between 1 and pi, greater than or equal to 1 and strictly less than pi, and the function is equal to x squared minus 1 for values of x that are greater than or equal to 1. So we are required to find this number a, which is appearing here, that makes the limit of x as x goes to 1 exists. Okay. Well, we know the limit exists if the limit of the function of x as x goes to 1 from left equals to the limit of x as x goes to 1 from the right side. So this means we need to calculate the limit as x goes to 1 from left and the limit as x goes to 1 from right. We equate them, and then we are going to get an equation involving a. This equation is going to help us to find a. So let me do first the limit from left side. So say here the first one is the limit of the function of x as x goes to 1 from left. See here, when I take this limit as x goes to 1 from left, see here, x goes to 1 from left, it means that the x values are less than 1. So which part of the function should I use? The first or the second or the third? The values of x are greater than 1. Here too are greater than 1. In this case, it is less than or equal to 1. So I am interested in the values of x where they are less than 1. So this is my part. I'm going to use this part of the function. So in this case, this limit is equals to the limit of the function, and the function in this period, okay, in this region is going to be a minus 2x as x goes to 1 from left. You see, as x goes to 1 from left, this is just a constant. As x goes to 1 from left, this one is going to go to what? To 2, right? So this will be a minus 2. This is the value of the limit of the function as x goes to 1 from the left side. Now let's calculate the other limit. So which is the limit of x as x goes to 1 from the right hand side. When we say x goes to 1 from the right hand side, it means that the values of x are strictly greater than 1, right? And I'm going to see which is my interesting period. Is this one greater than 1? Well, this is not just greater than 1. This part here is just greater than 1 because this is greater than 1 and less than pi. So my function for this part is this one, 5x plus 9. Therefore, I'm going to have limit of the function, which is 5x plus 9 as x goes to 1 from the right side. Now, when x goes to 1 from the right hand side, you see this quantity is going to go to 5, isn't it? So 5 plus 9, that will be 14. So I got the first limit and the second limit. What do I require now for the limit to exist? They must be equal. the first limit and the second limit must be equal. So then I require a minus 2 to be equal to 14. This means that a is equals to 16. I will repeat this part only, okay? Then I require the first limit to be equal to the second limit. So a minus 2 is equal to 14, which gives me a equals to 16. So when I put this number 16 here, okay, the limit from left and the limit from right will be equal, and therefore the limit of f of x as x goes to 1 will exist. Thank you. In this exercise, we are going to check if the following limit of the function absolute value of x minus 1 divided by x squared plus 2x minus 3 exists or not. And for this, as we said earlier, we have to check the limit from the left and the limit from the right, and if they are equal to a finite number, then it does exist. Otherwise, it doesn't exist. So let's see. So I'll first here in fact as x goes to 1, okay? So I'll check first the limit of the function absolute value of x minus 1 divided by x squared plus 2x minus 3 as x goes to 1 from the left. Let's calculate this limit. As we said, if x goes to 1 from the left side, it means the values of x are strictly less than 1. And in this case, in fact, we are going to have the limit as x goes to 1 from the left. This absolute value for x less than 1 is going to become minus x minus 1. All right? And this one, see here, this limit, in fact, when x goes to 1 from left or right, you see, it takes the form 0 over 0, because this one gets closer and closer to 0, and this one as well, when x goes to 1 from left, it will be 1 plus 2, that's 3 minus 3, so it is of this form, 0 over 0. And what I'm doing here, I'm trying to simplify things and factor so that I can find the limit. So here, see, my goal is to find a factor x minus 1 in the numerator and x minus 1 in the denominator, because x equal to 1 is a 0, in fact, is a root, okay, for the quantity in the denominator and numerator as well. So you see, this polynomial can be factored as follows. It's going to be x minus 1 times x plus 3. As you can see now, I can simplify my calculations as x goes to 1 from the left side. Okay, these factors can be cancelled out. So this one equals to the limit of the things left over, okay, minus 1 divided by x plus 3. And here as x goes to 1 from the left side. As you see here, as x goes to 1 from the left side, okay, this quantity is going to be negative 1 divided by this. X goes to 1 from the left side, so this gets closer and closer to 1, okay, and this is 3, so it will be negative 1 over 4. So this is the first limit. The first limit is negative 1 over 4. We need now to calculate the second limit and see if it is equal to this or not. Okay, the second limit, the limit of absolute value of x minus 1 divided by x squared plus 2x minus 3 as x goes to 1 from the right side. Here too, as x goes to 1 from the right side, it is of the form, in fact, 0 over 0. See here, as x goes to 1 from right, this quantity goes to 0. And as x goes to 1 from right, this goes to 1, 2. So 1 plus 2 is 3, minus 3 is 0 over 0. And therefore, I'm trying to find factors, the factor x minus 1 in both numerator and denominator. But since x goes to 1 from the right side, it means x is strictly greater than 1. And therefore, I can simplify the absolute value. So since x is greater than 1, the quantity inside the absolute value becomes positive, and therefore this absolute value simplifies to what? X minus 1. Very good. Okay, the denominator, like before, okay, can be factored as x minus 1 times x plus 3. Okay, here are some simplifications. So this factor simplifies with this factor, leaving just 1 over x plus 3 as x goes to 1 from the right. See here, this limit becomes very simple now after simplification. As x goes to 1 from right, so the numerator is just 1, and the denominator, this is getting closer and closer to 1 plus 3, so this is 1 over 4. As you see here, the first limit was negative 1 over 4, while the second limit is 1 over 4. They are different, okay? Hence, the limit of the function, I will call it f of x, as x goes to 1 from right, it is not equal to the limit of f of x as x goes to 1 from left, right? Because this one is 1 over 4, and this one is negative 1 over 4. Therefore, so the limit, the absolute value of x minus 1 divided by x squared plus 2x minus 3 as x goes to 1 in general, okay, does not exist. You see here, the limit from the left side does exist. It is negative 1 over 4. And the limit from the right side does exist. It is equal to 1 over 4. But because the two limits are not equal, then we say the limit does not exist. That's it. Let's see now together how we evaluate the following limit, okay, involving square roots, okay, where we need, in fact, here to multiply by the conjugate in order to simplify the limit. So we have the limit of square root of x squared plus 100 minus 10 divided by x squared as x goes to 0. Before I multiply by the conjugate, I have to check one thing, if I need to multiply by the conjugate or not. You see, as x goes to 0, the denominator is getting closer and closer to 0. Let's check the numerator. As x goes to 0, the quantity inside is going to go to 100, and its root, it's going to be what? It's going to be just 10. So this part, the first quantity is going to be 10 minus the other 10, so this will be 0 over 0. So this means when it is 0 over 0, the denominator has x as a factor, and the numerator too must have an x as a factor. And this is how I simplify. So what I'm going to do, this limit, in fact, is equal to the limit of square root of x squared plus 100 minus 10 divided by x squared. In order to free this quantity, okay, free the numerator from roots, I'm going to multiply the numerator, okay, by its conjugate. Its conjugate is the square root of x squared plus 100 plus 10. Okay, you see the plus here, so that when I multiply them, it becomes just difference between two squares, and the square is going to simplify the root. So divided by the same quantity, of course, because I'm multiplying just by 1. I'm not changing the quantity. This quantity and this quantity are the same, because this quantity is this, and this one is just what? 1, because this quantity divided by the same thing. Now, let's simplify now. So this is the limit as x goes to 0 of this times its conjugate. This is basically a difference between two squares. So the first square minus the second square. Minus the second squared, okay? So this is the root of x squared plus 100 squared minus the second squared, so minus 10 squared, divided by the multiplication of the numerators. So it will be x squared times square root of x squared plus 100 plus 10. Let's go no further and simplify the things. So this one equals to what? Equals to the limit of the square root x squared plus 100 is going to simplify to x squared plus 100 minus 10 squared. It is 100 as well. And downstairs you have x squared times square root of x squared plus 100 plus 10 outside the root. As x goes to 0. You see here, things simplify. So this is equals to only x squared divided by x squared times the square root of x squared plus 100 plus 10. As you see, this quantity simplifies with this quantity here, which makes it equal to 1 over, let me write it in a second line, which makes it 1 over limit as x goes to 0 is 1 over the square root of x squared plus 100 plus 10. Let's see now. As x goes to 0, the inside quantity goes to where? Goes to 100, right? Because 0 plus 100 goes to 100. So, and the root of the 100 is going to be what? Is going to be 10. So this goes to 10. So this limit is going to be equal to 10 plus 10, okay, which is 1 over 20. So simple. Basically, once we discovered that the limit is of this form 0 over 0, to make the simplifications, we multiplied by the conjugate. Multiplying by the conjugate is easy. It basically leads us to difference between two squares, okay? And the square of the first term minus the square of the second term, okay? And as you see, things are going to simplify, and eventually you can evaluate the limit easily. Yes, no, let's take the second problem where we need here, in fact, also to multiply by conjugates. The limit of the function square root of x minus x squared divided by 1 minus root of x as x goes to 1. As you see here, as x goes to 1, the denominator is going to go to 0. And the numerator as well will be 0 minus 0. So it is of the form 0 over 0. Then there must be, since 1 is a root for the denominator and numerator, so it means I must be able to obtain x minus 1 as a factor from the denominator and numerator. Okay, and for this, I'm going to do some simplifications. For instance, in order to simplify the denominator, I'm going to multiply by the conjugate of the denominator. So this is the limit as x goes to 1. The conjugate of the denominator is 1 plus root x. Okay, so I'm multiplying by a quantity which is exactly 1. And this is the numerator, root x minus x squared. Now, multiplying by the conjugate of the denominator is going to make things little simpler. So this will be, the product here will be 1, the first square minus the second square, so it will be minus x. So I already obtained 1 minus x from the denominator, okay? And the numerator is going to be the square root, say 1 plus square root of x times square root of x minus x squared. What I can do here, I have the choice to multiply by the conjugate of the numerator, the conjugate of this one, or another way, I can just multiply and simplify and see what happens. Okay, this one equals to the limit as x goes to 1, the denominator is 1 minus x. Let's multiply the numerator. So 1 times root x. So here is root x. Let me just group the roots first together. So 1 times root x, and here I'm gonna get another root. So minus x squared root x. And the terms without roots, okay, is going to be what? 1 times x squared, okay, so it's going to be minus x squared. And the other one is root x times root x, so it will be plus x, okay? Let's see here. There are some common factors. As x goes to 1, the denominator is 1 minus x. The numerator is, I can take root x as a common factor, so which leaves me having 1 minus x squared. Okay, and here, if I take minus, for example, x, okay, it will be 1 minus x. Okay, it will be 1 minus, no, it will be, if you take just plus x, it will be 1 minus x. I like to have 1 minus x in order to simplify it with the denominator. Now, I can simplify it with the denominator if I have 1 minus x in here. So I can factor, look here, I do. I have it in 1 minus x squared. Okay, let me just factor that out. So this is square root of x times the 1 minus x squared can be written as 1 minus x times 1 plus x. Isn't it? Plus x times 1 minus x. It is a little bit lengthy, but you know, when you just employ your background, mathematical background here, you will find it just easy. Okay, just you need to be patient. Now here I can take 1 minus x as a common factor in order to cancel it with the denominator. Once I have this done, I am done. So this is the limit as x goes to 1. Gonna take it now, 1 minus x as a common factor. Open a bracket. So it will be the square root of x. Things left here, 1 plus x plus x divided by 1 minus x. As you see, things now simplify, and I obtain the limit of root x times 1 plus x plus x, this thing, as x goes to 1. Now, as x goes to 1, this quantity is going to go to 1, this quantity is going to go to 2, this quantity is going to go to 1. So 1 times 2 plus 1. So it will be 1 times 2 plus 1, which is equals to 3. I hope you found this very interesting. Thank you.
Let us solve the following interesting limit. When x goes to -4, the numerator goes to -8 plus 8, and the denominator goes to 16 minus 4 minus 12. And as you can see, this limit is of the form 0 over 0. We cannot just say the limit does not exist because it is of the form 0 over 0. X equals to -4 makes the numerator and the denominator equal to 0, means x plus 4 is a factor of the numerator and the denominator. And to see this, I will factor both the numerator and the denominator. So this is the limit as x goes to -4. I'll take 2 as a common factor here, and as you can see, x plus 4 is already there. And in the denominator, it is in fact x plus 4 times something. What is it? It is times x minus 3. This is very interesting now, because I can simplify the limit, and it just becomes the limit as x goes to -4 of 2 divided by x minus 3. You see now this limit is not of the form 0 over 0, and I can compute it very easily. It is what? It is 2 divided by -4 minus 3, and it is just -2 over 7. It's very simple and so interesting. In this example, when x goes to 9, it is going to be of the form 9 minus 9 divided by 3 minus root of 9. And it is of the form 0 over 0. And to calculate this limit, I will multiply by the conjugate of the denominator. So this is the limit as x goes to 9 of 9 minus x divided by 3 minus square root of x times the conjugate is 3 plus square root of x, and I'm just multiplying by 1. And this quantity will simplify, in fact, what? When you multiply the denominators, this is just difference between two squares. So the first square, it is 9 minus the second squared, which is x. And the product of numerators will be just 9 minus x times 3 plus root x. As you can see, we can simplify things here. 9 minus x with 9 minus x. So then I have the limit as x goes to 9 of 3 plus root x. And when x goes to 9, this quantity will become just 3 plus 3, which is 6. So simple. Now let's see how to solve this interesting problem. When x goes to 2, the numerator goes to square root of 9 minus 3 divided by 2 cubed, that's 8, minus 4 times 2, which is minus 8. It is of the form 0 over 0. To simplify now this limit, I'll multiply by the conjugate of the numerator. So this is the limit as x goes to 2. So it will be square root of x plus 7 minus 3 divided by x. I can factor the denominator as x times x squared minus 4 times the product, the conjugate of numerator is what? Is square root of x plus 7 plus 3 divided, of course, by the same quantity, just to multiply it by 1. Alright, so plus 7 plus 3. Now when you multiply the numerators, okay, it just becomes product of difference between two squares. So the first squared is x plus 7 minus the second squared, which is 9. And I can factor this. If you can see, this is just x times x minus 2 times x plus 2, and the whole quantity times this square root of x plus 7 plus 3. As you can see here, the numerator simplifies to what? Simplifies to x minus 2 divided by x times x minus 2 times x plus 2, alright, times square root of x plus 3, x plus 7 plus 3. Alright, and see here, x minus 2 cancel out with x minus 2, and the value of this limit is very simple. So it will be 1 divided by 2 times 2 plus 2, that is 4, times the square root of 2 plus 9, that is 2 plus 7, that's 9. So it's 3 plus 3, which is 6, becomes 8 times 6, okay? So it is 1 over 48. So simple and so cool. See now the following problem. When x goes to negative 2, the numerator goes to negative half plus half, and the denominator is negative 8 plus 8. So it is 0 over 0. I will go and simplify things. I can write the numerator as x plus 2 divided by 2x, and the denominator is in fact the sum of 2 cubes. I can factor it as x plus 2 times x squared minus 2x plus 4. We just organize things now. It becomes x plus 2 divided by 2x times x plus 2 times x squared minus 2x plus 4. See here, things are nicer. I can simplify x plus 2, and this gives me the limit as x goes to negative 2 of 1 divided by 2x times x squared minus 2x plus 4. It is not of the form 0 over 0 way, where I can just substitute negative 2 and find the value of the limit. It is equal to 1 divided by negative 2 times negative 2 times, and that is 4 plus 4 plus 4. So it becomes 4 times 12, which is negative 1 over 48. Let's see how to calculate the following limit. When t goes to 1, the numerator will go to 3 times 1 squared minus 3, that is 0, divided by sine 1 cubed minus 1, that is sine 0, and we know sine 0 is 0, so it is of the form 0 over 0. To calculate this limit, let me first remind you of something. Say you have the limit of sine x divided by x as x goes to 0. We know that this limit equals to 1. Similarly, when I have the limit of the reciprocal x divided by sine x as x goes to 0, this is also 1. We have, in fact, a more general result that says if the limit of any function of x, where x goes to some point x0, suppose this limit is equals to 0, then in fact we have the limit of sine of this function divided by the same function as x goes to x0 is also equal to 1. As long as the argument of sine goes to 0 divided by the same argument, okay, then the limit will be 1. Similarly, we have the limit of f of x divided by sine of x as x goes to x0 equals to 1. Of course, we have to have this condition. If the argument inside the sine, if this argument goes to 0 as x goes to x0, okay, and we have the same argument here, okay, then this limit is going to be 1. We have the same situation in our problem here. See here, as t goes to 1, the argument of sine, which is t cubed minus 1, goes to 0. So this is a right a place to apply this result. So as t goes to 1, I wish to have sine t cubed minus 1 with numerator the same as the argument, which is t cubed minus 1. And of course, if I place this quantity, I have to divide by the same quantity. Alright, and I will have the numerator, this one, which is 3t squared minus 3. Now I can see that this quantity here, the limit of this quantity is going to be 1. So I'll just distribute the limit. So the limit of the first times the limit of the second. So it will be the limit of t cubed minus 1. T cubed minus 1 divided by sine t cubed minus 1 as t goes to 1. Okay, times the limit of 3t squared minus 3 divided by t cubed minus 1 as t goes to 1. As you see, the first limit is very easy, which is 1, okay, times the second limit. Now the second limit as t goes to 1, it will be what? It will be, you can take 3 as a common factor, so it will be t squared minus 1 divided by t cubed minus 1 and it is of the form 0 over 0. Well, this is going to be simple. I will factor the numerator and the denominator. So this will be the limit as t goes to 1 of 3 times t minus 1 times t plus 1 divided by factoring now t cubed minus 1 gives us t minus 1 times t squared plus t plus 1. See, here we have some simplifications. So the t minus 1 goes with the t minus 1. So, and the value of the limit will be simply 3 times 2 divided by 1 cubed plus 1 divided by 3. And the answer to this limit is just what? 2. Very good. In the following limit, as x goes to 1 from left, we know the numerator is going to go to where? 1 squared minus 3 plus 2, and the denominator goes to 1 minus 1. So it is of the form of 0 over 0. Well, to compute this limit, we factor. Now, as x goes to 1 from left, the denominator is easily factored as x minus 1 times x plus 1. And the argument of the absolute value is going to be factored as x minus 1 times x minus 2. Okay, very good. Now we simplify the things. So we have what? I will distribute the absolute value in the numerator. So as x goes to 1 from left, this is going to be the absolute value of x minus 1 times x minus 2 divided by x minus 1, okay, times x plus 1. Note here, when x goes to 1 from left, this means that x is less than 1. It's strictly less than 1, and therefore, look here, the absolute value of x minus 1 is going to be the argument of this absolute value, the x minus 1, is going to be negative, right? And therefore, this value, the absolute value of x minus 1, is going to be minus x minus 1, which is here x, the absolute value of x minus 2. When x goes to 1 from the left side, it's just less than 1. The quantity inside the absolute value is negative, and therefore it's going to be multiplied by negative 1. So it will be negative x minus 2. So I'll put these values now in the limit. So this will be the limit as x goes to 1 from left times of negative x minus 1 times another negative, okay, negative x minus 2, the whole thing divided by x minus 1 times x plus 1. As you can see, I can simplify the signs. This sign, the negative times the negative, okay, is going to be just positive. And I can also simplify this factor with this factor, leaving the limit of x minus 2 divided by x plus 1 as x goes to 1 from the left. As you see now, this limit is not of the form 0 over 0. As x goes to 1, okay, the numerator goes to 1 minus 2, which is negative 1 divided by 2. It's very simple, but we need to care about how to calculate or simplify the absolute values. In this limit problem, as x goes to 1, the first factor is going to go to sine of pi, which is 0. And the second factor, as x goes to 1, it will be cosine pi divided by 0. So the quantity inside the cosine is going to go to plus infinity or minus infinity, and therefore the limit of the second factor is undefined. Okay, it does not exist, and therefore we cannot just distribute the limit. We cannot say that this is the limit of the first times the limit of the second, because we can do that when both the limits exist. So what can we do to solve this problem? What we are going to do here is to apply the Sandwich Theorem. I know, let me just first remind you of something. Say, for example, you have sine function or cosine function. Sine of, say, for example, of x. If you have sine of any function, this quantity is going to be between -1 and 1, because the range of sine is between -1 and 1. And in fact, even if you have, for example, cosine or sine, the same thing, right? Say, for example, you have g of x times sine of x. Now, the maximum value that this quantity can take as g of x if it is positive, right? And if it's negative, it's going to be minus g of x. So in general, the maximum value is the absolute value of g of x. Remember, the maximum value of this quantity is what? Is just 1. And the minimal value is going to be minus the absolute value of g of x. Now, this remark is very useful. For example, if you had, say, for example, h of x times cosine k of x, what is the maximum value this quantity can take? The maximum value is the absolute value of the coefficient of the cosine. So it is the absolute value of h of x. And the minimal value, okay, this quantity can take is minus the absolute value of the coefficient of cosine. So it is minus the absolute value of h of x. I will apply this result, okay, to solve this limit problem. So what I will do, I will first take sine pi x, okay, times cosine pi 1 minus x. As you see, I'll take now this quantity is going to be, see here, the coefficient of sine x is this one. So let me write it as this. It is just cosine pi 1 minus x times sine pi x. I don't like this term, okay, because when x goes to 1, its limit does not exist. So I will sandwich the whole quantity here between something and something, okay? So what is the coefficient of sine here? The coefficient of sine is this quantity. Okay, so this quantity is going to be less than or equal to. Now I will apply this result to solve the following problem. I know that sine pi x times cosine pi divided by 1 minus x is sandwiched, okay, I'm using a sandwich theorem, in fact, is sandwiched between minus absolute value of sine pi x and the quantity is less than or equal to the absolute value of sine pi x. Now let me take the limit, okay, to each side. So what I will have here, see the limit of the left side, this limit here, the limit of minus absolute value of sine pi x as x goes to 1 is 0. Okay, that's one thing. The second thing, the limit of the right side, which is the sine of pi x as x goes to 1 equals to what? 0. Then by sandwich theorem, then from sandwich theorem, I have the following: the limit of the middle quantity has to equal to the two limits. So the limit of sine pi x times cosine pi divided by 1 minus x as x goes to 1 equals to 0. It's very simple. Now you see the limit of the left side is equal to 0 and the limit of the right side equals to 0 as well. Then I can apply the sandwich theorem. So I'm going to write this from the sandwich theorem, from the sandwich theorem. From the sandwich theorem, what do I have? I have to have the limit of the middle quantity must be equal to the other two limits, okay? So the limit of sine pi x times cosine pi divided by 1 minus x as x goes to 1 equals to 0. Very interesting. In the following limit, when x goes to 0, I know the first term goes to 0, but the second term, the second factor, does not exist. See here, when x goes to 0, the power here will be cosine of plus or minus infinity, so it doesn't exist. And therefore, I cannot pass the limit. I cannot say it's the limit of the first times the second. This limit is another application of the sandwich theorem. Note here, when x goes to 0, the limit of the first factor is 0, but the limit of the second factor does not exist. This question is another application of the sandwich. This problem is another application about the sandwich theorem. See here, as x goes to 0, the first factor goes to 0, while the second factor, the limit of the second factor, does not exist, because as x goes to 0, this amount, cosine, the limit of cosine 1 over x does not exist. And therefore, we cannot just say the limit of absolute value of x times the limit of e to the power cosine 1 over x. And so what do we do here? I will implement the sandwich theorem. I will start this way. It's very simple. So I know first that cosine 1 over x is between -1 and 1. what I'm going to do here, I'm going to build my function. So I first have what? I first have cosine of 1 over x. Then I'm going to apply the exponential function to each side. I know the exponential function is increasing, the e to the power x is increasing, and therefore I will not interchange the inequality. Okay, so it will be e to the power minus 1, e to the power cosine 1 over x less than or equals to e to the power 1. If I'm dealing with, for example, not e to the power x, say for example I deal with say for example half to the power x, okay, then I have in this case I will have to change the inequalities, okay, because this function half to the power x is a decreasing function. Anyway, e to the power x is an increasing function, and that's why we just have kept the inequalities. Now the other thing, I'm going to have the absolute value of x. I will multiply each side by the absolute value of x. So this will give me the absolute value of x is non-negative, so this will not change the inequality. So it will be absolute value of x e to the power minus 1 less than or equals to absolute value of x e to the power cosine 1 over x less than or equals to absolute value of x times e to the power 1, or just simply e. Notice here the limit of the right side and the limit of the left side. Let me calculate this. The limit of the left side, which is absolute value of x e to the power minus 1 as x goes to 0, is equal to 0. And also the limit of the right side, which is the limit of absolute value of x times e as x goes to 0, is also 0. Then I can apply here the sandwich theorem. Okay, then by the sandwich theorem, by the sandwich theorem, the limit of the middle quantity must equal to the value of the other limits. So the limit of absolute value of x times e to the power cosine 1 over x as x goes to 0 is equal to 0. Very simple and interesting. In this limit problem, we are given that the limit as x goes to 2 of f of x minus 2x plus 3 divided by x minus 2 is equal to 1. So the limit exists. And we would like to find the limit of f of x as x goes to 2. So this is our unknown. I will solve this problem by using the properties of limits. So what I know first, I know I'm given that this limit of f of x minus 2x plus 3 divided by x minus 1 equals to 1 when x goes to 2. I would like to find the limit of f of x as x goes to 2. A simple way is to multiply both sides by the limit of, the denominator here as x minus 1, just to free the denominator. So it will be what? The limit of x minus 1 as x goes to 2, right? This question. Repeat. In this question, we are given that the limit as x goes to 2 of f of x minus 2x plus 3 divided by, repeat. In this problem, we are given that the limit as x goes to 2 of f of x minus 2x plus 3 divided by x minus 2 is given to be 1. And we would like to find the limit of f of x as x goes to 2. See here, I will use the properties of limits in order to solve this problem. It's very simple. So I'm given the limit as x goes to 2 of f of x minus 2x plus 3 divided by x minus 2 equals to 1. And I would like to find the value of the limit of f of x as x goes to 2. Well, then I will need to free the denominator. I'm going to multiply both sides by the limit of the denominator, x minus 2 as x goes to 2, both sides. Okay, you see, I know the first limit is 0, but I will simplify the second limit because this limit is going to be as a single limit. So it will be the limit as x goes to 2 of the product of two limits. Okay, so it will be x minus 2 times f of x minus 2x plus 3 divided by x minus 2. Okay, and the limit of the right hand side will be just 1 times 0, which is 0. Very simple. And the interesting thing here is x minus 2 cancels out with x minus 2, leaving what? Leaving the limit of f of x minus 2x plus 3 equals to 0 as x goes to 2. Now I can distribute the limit. So it will be the limit of f of x as x goes to 2 minus 2 times the limit of x as x goes to 2 plus the limit of 3 as x goes to 2 equals to 0. And this is very simple. This is just what? This is the limit of f of x as x goes to 2 minus 2 plus 3 equals to 0. So the limit of f of x as x goes to 2 will be negative 3 plus 2, which is negative 1. I just use the properties of limits to solve this problem. In this problem, we are given that the limit as x goes to 2 of f of x minus 2x plus 3 divided by x minus 2 equals to 1. And we would like to find the limit of f of x as x goes to 2. Here I will use the properties of limits to solve the following problem. We are given that this limit of x minus 2x plus 3 divided by x minus 2 as x goes to 2 equals to 1. And I would like to find the limit of f of x. Here, in order to simplify things, I will multiply by the limit of the denominator in order to cancel it out, and things will simplify. You will see now. So I'll multiply by the limit of x minus 2 as x goes to 2. Of course, this limit is 0, but that's okay. Times the limit x minus 2 as x goes to 2. You see, in the left-hand side, the limit of the first times the limit of the second will be the limit of the product, okay? So it will be the limit of x minus 2 times f of x minus 2x plus 3 divided by x minus 2 as x goes to 2. And you know, this is the right hand side is just 1 times the limit of x minus 2 as x goes to 2 is going to be just 0. The nice thing here is that I can simplify. So, and this will be the limit of f of x minus 2x plus 3 as x goes to 2 equals to 0. And now I want to find the limit of f of x. Simple, I will just distribute the limit. So it will be the limit of f of x as x goes to 2, okay, plus or minus the limit of 2x as x goes to 2 plus the limit of 3 as x goes to 2 equals 0. So what do I have here? I have the limit of f of x as x goes to 2 minus the limit of 2x as x goes to 2 is 4, so it will be negative 4, plus the limit of 3 as x goes to 2 is just 3, so it will be negative 4 plus 3 equals to 0. So what is the limit of f of x? Then the limit of f of x as x goes to 2 is simply 1. Very interesting and easy.